algebraic identities and factors. If x squared minus ax plus b is a factor of x cubed plus 2ax squared plus 4bx plus c, using algebraic identities, we can find a relationship between the coefficients a, b, and c. It's important to realize that when a factor is divided into an expression, there can be no remainder by definition of a factor. So if we do algebraic long division, we can see there is a remainder left over here. So we have x times 3b plus 3a squared plus c minus 3ab. So we would consider the c minus 3ab to be the constant because there's no x attached. So since there can be no remainder, we can conclude that for all values of x, 3b plus 3a squared is equal to 0, i.e. b is equal to minus a squared, and c minus 3ab is equal to 0, i.e. c is equal to 3ab. We will look at an example similar to this in a couple of minutes in detail. The same results can be obtained by letting the missing factor equal x plus k. So we would have x plus k multiplied by x squared minus ax plus b is equal to x cubed plus 2ax squared plus 4bx plus c. Expanding the left-hand side, we get x cubed minus ax squared plus bx plus kx squared minus akx plus bk is equal to x cubed plus 2ax squared plus 4bx plus c for all values of x. And then grouping the like terms, we still have the x cubed on its own. And then we're going to factorize. So we're going to take the kx squared and the minus ax squared and factorize out the x squared. And then we're going to take the bx and the minus akx and factor out the x. And then just bring down the bk. And that's still equal to the right-hand side. So just taking this step again from the previous slide. So you'll see I've highlighted all the different bits that are going to match. So x cubed matches with x cubed, so like to like. K minus ax squared matches with 2ax squared, so they're the x squared terms. They will equate in a minute. B minus akx is going to equate to 4bx, putting like to like, and then bk will equate to c. So comparing the coefficients of x squared, so our x cubes will just cancel, so we move straight to the x squareds. And the x squared parts will cancel, so we have k minus a equals 2a. So k will be equal to 3a, which is the same as in the algebraic long division method. And then for our coefficients of x, so the x's would cancel, leaving b minus ak is equal to 4b. So we get b minus 3a squared because k is equal to 3a. So we get minus 3a squared equal to 4b. Hence 3b is equal to minus 3a squared, i.e. b is equal to minus a squared, which is the same as in the algebraic long division method. And finally, comparing the constant terms. So the k was equal to 3a, so we get 3ab is equal to c. And again, that's the same as in the algebraic long division. So just quickly going back to the algebraic long division method. So we can see c is equal to 3ab, b is equal to minus a squared. The factor was x plus 3a. So again, c is equal to 3ab, b is equal to minus a squared, k is equal to 3a. So let's have a look at an example in detail now. So example 4, given that x minus t to be squared is a factor of x cubed plus 3px plus c, show that p is equal to minus t squared and c is equal to 2t cubed. So for rough work, we're going to do x minus t to be squared, which gives us x minus t times x minus t, and simplifies to x squared minus 2tx plus t squared. So we set up our algebraic long division bus stop, and instead of x minus t to be squared as our factor, we're going to have x squared minus 2tx plus t squared. So this is our highest common factor. So this is going to divide into x cubed plus 3px plus c. I'm going to add in a 0x squared because there is no x squared term. So then we start with the highest power of x inside the bus stop, which is x cubed, divided by the highest power of x outside the bus stop, which is x squared. Our answer is x, which goes on top of the bus stop. Then we're going to multiply the x by x squared minus 2tx plus t squared. And we end up getting x cubed minus 2tx squared plus t squared x. Be very, very careful here with your rough work on where you put your squareds. So that gets written down up here. We change the signs. The cubes will cancel. We bring down the 2tx squared. Then we bring down the minus t squared x. We bring down the plus 3px. And we bring down the plus c. So we can't combine these. These are not like terms. Then we go again. So we're going to factorize, first of all, this line anywhere we can. So I'm going to factor out the x from these two terms. So I have minus t squared plus 3p inside the brackets, and everything else remains the same. So bringing down the 2tx squared and the plus c, and just factorizing the minus t squared x plus 3px. So then we take the highest power of x inside the bus stop, which is 2tx squared. So that's coming from here. We divide it by the highest power of x outside the bus stop, which is x squared. And we get 2t, which goes on top of the bus stop. So then we multiply that 2t by x squared minus 2tx plus t squared. And we get 2tx squared minus 4t squared x plus 2t cubed. So again, be really careful with your powers here and where you put your powers. So we write that underneath here. Notice that I have the squared under the squared, the x squared under the x squared, the x term under the x term, and then the constants under each other. So I know there's a c and a t there, and they are obviously letters, but we still consider them to be constants because there's no x term attached. So we change the signs. The squares will cancel. So focusing just on these two x terms now. We're going to bring down the minus t squared. We're going to bring down the 3p. And we're going to bring down the plus 4t squared. And all of that has brackets around it with an x stuck on at the end. So that's our x term. We would consider this a single term. And now we're going to bring down our constants. So our constant is c minus 2t cubed. So we would consider this, everything you see here in blue here, to be our constant term. We would consider this to be one term. So we're just going to simplify here. So minus 1t squared plus 4t squared will give us 3t squared. And we still have the plus 3p, and it's still stuck onto x. And we bring down the constant again. So this is our remainder. But since we should have no remainder, 3t squared plus 3p x plus c minus 2t cubed must be equal to 0. So we let the remainder equal to 0 for all values of x. So I just have repeated the last sentence there. So 3t squared plus 3p x plus c minus 2t cubed is equal to 0x plus 0. So we had already said it was equal to 0 because we know that there actually can't be a remainder because we're told that this is a factor. So I'm adding in the 0x here. So I'm going to put like to like. So the yellow parts will equate and the blue parts will equate. So focusing on the x terms now, the yellow parts. So I have 3t squared plus 3p x is equal to 0x. The x's will cancel. So we have 3t squared plus 3p is equal to 0. And dividing across by 3, we get t squared plus p is equal to 0. So p is equal to minus t squared. And that's what we were asked to show. That's one of the things that we were asked to show. So p is equal to minus t squared. So then putting like to like, we get c is equal to positive 2t cubed, which is what we were asked to show. So c is equal to positive 2t cubed. All we did there was carry the minus 2t cubed over the equal sign to become positive. As required.